Okay, so today we're going to do something called symbolic logic. I actually took a logic class in college where we did a lot more than this, but this is one of the things we did. We did some really, really, really ugly ones. We're going to try and stay away from the really ugly ones. But it's kind of interesting, I think, at least. Hopefully you'll like it. So a compound statement is created by combining two or more statements. Primarily, we have two types. A conjunction, which is a compound statement using the word and. It's true only when all of its parts are true. Okay? So if you say P and Q, which is written this way, P and then this symbol, which looks like a capital A kind of. I think that makes it easier to remember that it's and. So P and Q. It's only true if P is true and Q is true. They both have to be true. Not one or the other. Both of them have to be true. As opposed to a disjunction, which is a compound statement using the word or. It's true if any of its parts are true. So in words P or Q, symbolically, P and this symbol that looks like an upside down, capital A, is or, P or Q. If either one of them, either P or Q, is true, this is a true sentence. Okay? There are sometimes, and this is something we did in my class, there's one called an exclusive or, where it can only be one of them, right? Either this one or this one, but not both. We're not going to do that. We're just doing this one or this one, either one, or it could be both. We're happy with that. All right, so let's look at some basic examples of this. So here are three statements. Austin is the capital of Texas, is going to stand for P. Pecans grow on trees, that's going to stand for Q. And animals with wings can fly is going to stand for R. Before we go through this, let's assign truth values to all of these. So for this first one, Austin is the capital of Texas.
True.
That's true. Pecans grow on trees.
True.
True?
That's also true. By the way, what is the most common nut that does not grow on trees?
Peanuts.
Peanuts. Because they're not actually nuts at all.
What are they?
They are a legume.
Aren't like beans and like peas legumes?
Yes, they are.
Oh yeah, smart man.
Right?
It has to do something with the nitrogen content, and I don't know what all it has to do with. Biology is my weakest science.
Biology's made up.
It's made up.
Everything is fake.
And
Life is a lie.
animals with wings can fly.
False.
False.
That's very much false.
Dodo birds. Aren't they extinct?
Yes, they are.
Penguins.
So they don't. Penguins can.
Penguins don't fly.
They have like these tiny little wings and they just waddle.
Yeah.
What's up with
Penguins,
penguins' mouth?
emus, ostriches, kiwis.
They're birds. These are so cute. They are so cute.
All right, so let's find the truth value of each of these. So Q, and what is this a symbol for? Or. Q or R. And if you really want to get snotty about it, you're supposed to read it Q disjunction R, but almost no one does. Everyone's like, oh, that's Q or R. So is Q true?
Yeah.
Yeah, do I really care about R then?
No.
Nope. This is true. I only need one of them to be true.
But for the Q and R, both have to be true.
Correct. Which is our next example. P and R. Are both of those true?
No.
No, so this is false. Now, this one, this is from last week. What does this symbol mean?
Then
Yeah.
It's sort of like then. It's literally read implies, but it is like the then in that this would be read R implies Q, which is the same thing as saying if R then Q.
How does that make sense? Like, what does the truth value have to be the same?
Okay, we talked about this last week,
Sorry.
but let's talk about it again. So with if-then statements, and again, the one I always use is the lottery one. If I win the lottery, then I will give you $1,000. What is the only way you can prove I'm a liar?
If you win the lottery.
I have to win the lottery and,
Don't do it.
exactly, so the hypothesis has to be true and the conclusion has to be false.
Okay.
Okay? So with this one, the hypothesis is false, right? Nothing else matters. If the hypothesis is false, this is a true sentence, and that bugs students. They don't like it. Yes, ma'am.
What is winning the lottery, like, how many dollars do you have to get for it to be winning the lottery? Like what if you got, like, you scratched it and you got, like, $3? Is that winning?
Yeah, that's a scratch ticket. That's not the same as winning the lottery.
It's like
Winning the lottery, usually people are talking about one of the big lottos where, you have to pick 7 numbers and get them all right or something like that. Yes, ma'am.
So, number 3, if that's true, it would be false. So it's like,
If what was true?
if R was true,
If R was true, this would be true.
dude, what? But if it's false, it's true.
Okay, so here are the 4 possibilities for an if-then. True implies true. That's true. Right? I won the lottery and I gave you all the money. I gave you the money that I promised you. True implies false. I won the lottery, but I didn't give you money. So I'm a dirty liar. False implies true. I didn't win the lottery, but since I'm such a nice guy, I gave you all $1,000 anyway. So it's true. You can't prove that I lied. And I didn't win the lottery, and I didn't give you any money. Still true.
True.
You can't prove that I lied. So with an implication, an if-then sentence, a conditional statement, the only way you can say that it's false is if the hypothesis is true, but the conclusion is false.
Oh, okay.
Okay? Yeah, it's tricky.
I was confused because I thought it was the only way it was true. It was true false.
Gotcha. Yeah, the only way that it's false if it's true implies something that's false. All right. So let's take a look at this one. This little tilde symbol means not. So it has the opposite truth value.
Then why does it go over an equal sign when we're talking about?
It was developed by 2 different sets of people at 2 completely different times.
So.
Yeah, don't make a big deal out of it.
Okay.
But this stands for not. So not P or Q. Is not P true?
No.
No, that's false. It's an or, so we have to keep looking. Is Q true? Yes. So that's true. We only need one of them to be true. How about this one? Not Q implies P.
True.
That's true. Because not Q is
False.
false. And if the hypothesis is false, nothing else matters. It's going to be a true sentence. Yes.
Could you put the squiggle on the other side?
On the other side.
Of
Other side of what?
Of the A. Or the arrow.
That would change it to not P. Yeah. The not doesn't have to be on the first thing. It could be on the second thing. All right, and then not are. So what is this part's truth value?
True.
True, and it's an and, so we have to keep looking. Q. So that's true because they're both true. Now, this is fine if you know whether P and Q and R are true or false. But sometimes we want to look at, well, what are all the different possibilities? If we want to do that, then we do what's called a truth table. So a truth table lists all the possible combinations of truth value for a compound sentence or a compound statement. So, for example, here we want P implies Q. So first I need a column for just P and just Q. And I need to list all the different possible combinations that I could have for P and Q. And I'm going to leave lots of room over here because I'm going to fill this all in just a minute. There are lots of correct ways to do this. What I do is I usually start with trues and falses for the last one. I just go true, false, true, false. And then here I go true, true, false, false. If I had a third one, I would go true, 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 false, 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 false. Every time you add on another statement, you're going to double the number of possibilities. So with 2 statements, there are 4 possibilities. With 3, there are going to be 8. I don't think we do any with 4, but with 4 it would be 16. The number of possibilities just keeps doubling every time. All right? So let's look at P implies Q. So true implies something true. Is that true or false?
True.
That's true. Truth implies falseness.
False.
That's false. False implies true. That's true. And false implies false? True. All right. Then let's do P and Q. So if P and Q are both true, then that's true. P's true, but Q is false.
False.
False. P is false, but Q is true.
False. False.
That's false. It's an and. They both have to be true for this one. And P is false and Q is false.
True.
It's false. It's not they have to be the same. They both have to be true. Right? That would be like saying 2 wrongs make a right. All right, and then let's look at P or Q. So P is true, Q is also true. This is true. P is true, Q is false. True. P is false, Q is true. That's true. P is false, Q is false. False.
Is there always going to be one true? Or, never mind. There's always going to be one that's different?
At least one, yeah. Yeah, there's always got to be at least one that's different. I don't think you'll ever have something where it's all true or all false. All right, let's construct a bigger truth table now for not P and Q or R. Yikes, there's a lot of stuff there. But I start with just the basic parts. I've got a P, I've got Q, and I've got R. Since I have 4 different possibilities there, I'm going to have, 3 different possibilities there. I'm going to have 8 different possible combinations. So under R, true, false, true, false, true, false, true, false. Under Q, I'll do true, true, false, false, true, true, false, false. And then underneath P, I'll do true, 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 false, 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 false. That should get me every possible combination. By the way, if you want to know, well, how do I know what the number is? Since it's true and false, it's always 2. And then it's raised to the power of how many different things you have. So 2 to the third is 2 times 2 times 2. That's 8. If I had 5 things there, I would need 16 different combinations. Yes?
How did you, did you learn what the true falses were in each one? Or, do you know that?
It's just an easy way to do it. You have to get all 8 combinations. You could just try and think of all 8 combinations, but this is a real simple way to get all 8 combinations without having to rack your brain about, wait a minute, which one have I left off? Okay? All right. So now we're going to start reading our sentence. It starts off with not P. So I have to have a column for not P. Not P is simply going to have the opposite truth values that column P has. So this will be false, 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 true, 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 true. And then I want to have a conjunction of that with Q or V. So just like with order of operations, I've got to do what's inside this parentheses before I can combine it with the not P. So I need to do a column for Q or R. So Q or R, they're both true. That makes Q or R true. Q is true, R is false. What does that make Q or R?
True.
True. Q is false, R is true. Q or R then is true. Q is false, R is false. Makes Q or R false. And notice that exact same pattern that happened on these 4 happens on these 4. That's going to happen sometimes. If you notice it, it'll save you some time. So now I'm ready to put these 2 columns together. Not P and Q or R. So I'm just looking at these 2 columns right now. With an and, what has to happen? They both have to be true in order for this to be true. So this first one, not so much, that's false. The second one, that's false. Third one, that's false. Fourth one, that's false. Fifth one, oh, that's true. Sixth one is true. Seventh one is true. And the last one is false. Now again, in the class I took in college, they would do something like this. They would say, analyze the ones that are true. These are the 3 that are true. P had to be false. And one or the other of Q and R had to be true. Didn't matter which one. Okay? All right, let's do one more here. So I've got U, W, and V here. So I'm going to have 8 different possibilities. So true falses, two trues, two falses over and over again, and then 4 trues, 4 falses. By the way, although I'd ask you not to do it, it's not wrong if you did the first column, true, false, true, false, true, false, true, false, and then the next one, true, true, false, false, true, true, false, false, and then the last one, 4 trues and 4 falses. You would still have all the combinations. It just makes it difficult if, half the class is doing it one way and half the class is doing it another. All right. So what do I need for my next column?
U implies W.
Yep, U implies W. So let's see, if U is true, does that imply W is true? Yeah, that's true. This is exactly the same, so that's true. The hypothesis is true, but the conclusion is false.
Yeah, true.
That's false.
What?
That's the I win the lottery, but I don't give you the money.
Oh.
Right? The next one is the same. The next one, hypothesis is false. Actually, the next two, the hypothesis is false, but the conclusion is true. Is that true or false? True. And the hypothesis is false and the conclusion is false. That's true also. What do I need next?
W and V.
Yeah, W and V. So I need W and V. What's the only way that that's going to be true? If they're both true. So W and V both true here. They're not both true there. Not both true. Not both true. Here they are both true. And then not and not and not. And then I'm ready for my last column. U implies W, or W and V. So again, I'm just looking at the 2 previous columns. What do I need in order for this to be true? One of them to be true, and it doesn't matter which one, does it? So both true, that's good enough. One of them's true, that's good. Both false, that's false. Both false, that's false. One of them's true. One of them is true. One of them is true. One of them is true. Okay? Any questions about that? All right, then your assignment on this is in the book. Be sure you're ready for your quiz on Thursday also, over the first 3 sections in this. And our test on this will be next week, although we will, we'll start the next unit before then, because this is the last thing on this. It's just that our constraints on test days keep us from finishing the unit.
That's dumb.
It's the way it goes. normally what I would have done if this was a public school or something, we would be taking the quiz tomorrow, getting a review tomorrow, going over it on Thursday, and then taking the test on Friday. If you were on a school where you were on a 5-day regular